Hey Aurora, it's me again. It is Wednesday, about 5 o'clock, and I'm kind of just walking around in my backyard. Usually I take these videos in my front yard, but I figured, let me give you a little tour of the backyard here. So I'm kind of out on my deck. Another beautiful day weather-wise. I just checked, and it's about 81 degrees right now. That's the temperature. And remember, we measure temperature with a thermometer, so it's 81 degrees Fahrenheit in Hopewell, where I live. And the humidity is about, I think, 57%, so about halfway on the humidity. Remember, 100% would be full. And the dew point is kind of at that iffy, it's 64 degrees for the dew point. So it's kind of like, it's a tough one to call. It's slightly uncomfortable, but it's not too bad. So 64 for the dew point. And so far, I mean, clear skies, but I think some rain or precipitation is on the way. So for you, you're watching this, it's Thursday morning. Yesterday's lesson dealt with temperature, how hot or cold it is. And again, we measure that temperature with something called the thermometer. And in the United States, we use Fahrenheit. But the rest of the world, as you found out, use Celsius. And the scientific community also uses Celsius or sometimes Kelvin, you'll hear that scientists use. Scientists don't really use Fahrenheit. So temperature is how hot or cold it is. And that's very important for weather because the temperature, it's not always the same everywhere. So those differences in temperature can cause a lot to happen. So today you're going to learn about a word called heat. And heat is basically going from warmer to colder. That's heat transfer. And hot likes to go to cold. Now, the way hot can go to cold can occur in three different ways. And this should be somewhat familiar to you. I think we talked about this earlier in the year. But heat can be transferred. Remember, it goes from hot to cold in three different ways. So, for example, I'm out here right now and I'm still feeling the warmth of the sun, but I'm not touching the sun. So the heat's being transferred from the sun to me through a way called radiation. That's heat transfer when you're not touching the heat source. There's other examples of radiation as well, but the sun warming the earth and warming you and I is a very common example of radiation. All right, so that radiation is going to heat the lower layer of the atmosphere. That's going to affect the weather. Now, of course, it doesn't heat the whole atmosphere equally. Different parts of the atmosphere are warmer or colder. So radiation's one way. Another way is you can actually touch something that's hot. Like, for example, I'm walking around right now on my deck. You can kind of see my deck here. And if it was a really hot summer day, the flooring of the deck, if you're walking around barefoot, will burn the bottom of your feet and get really hot. I'm sure you probably also experienced that on like the sidewalk or maybe at the beach with the sand. If you're touching something that's hot, that hot goes into your colder body. That's another form of heat transfer. Hotter to colder, you'd be the colder object. That's called conduction. Conduction involves touching. Okay, so there's many different types of conduction that can happen. And lastly, the one that we get most confused about, but we've definitely talked about it before, is a heat transfer that occurs in a fluid. Now, a fluid can be, and I love this topic, it's one of my favorite. A fluid could be liquid, like water. It could be magma, that's another liquid, or it could be a gas like the atmosphere around us. That type of heat transfer where hot is moving to cold is something called convection. Now, you better believe that I hope that you've heard of that word before. Okay, because if you're saying I've never heard of convection, we've talked about convection a lot. And again, looking at my hands here, that swirling is called the convection current. So we've talked about convection currents happening in the earth, in the magma that moves the tectonic plates. We also looked at it with those little hole punches very early in the year, how they were moving around the beaker. That is a convection and a convection current. That's hot going to cold. That's a heat transfer, but it can only happen in a liquid or a gas. Now, convection currents are going to be so important because they're happening in the atmosphere around us in the lower troposphere. And if air's moving from warmer to colder areas, because remember, the Earth is not heated equally, that moving air or the convection current is going to cause something called wind. Okay, so this heat transfer, mainly the convection, is going to really affect our weather and the wind that we're going to get into after this topic. Now, wind can be small, like the wind you feel maybe in your yard or around South Brunswick, or it can be winds that travel the entire earth. So we have local versus global winds. So for today's assignment, and by the way, if you didn't finish yesterday's, no rush, but do yesterday's, Wednesday's first, and then move into Thursday's new work today. There's no rush to get things done, but you eventually have to get things done, okay? So make sure you're sort of keeping up with the work. But for today's work, you're gonna have a little section to fill in with some new textbook pages. It shouldn't take you that long. And I basically, if you were listening to this video, I went over all the answers already. But if you didn't watch this video for some reason, they're also on the textbook pages. But also there is going to be 3 pictures that you have to draw. One of radiation, one of conduction, and one of convection. So all the instructions will be on the Google Doc. Today's assignment for Thursday is also for tomorrow, Friday. So you have both days, today and tomorrow, to complete the little textbook piece and the 3 pictures. Keep in mind, the pictures for the instructions for the pictures are pretty specific. So make sure you follow those instructions and take a picture of what you did, and either attach the picture to the assignment, or if you're techie enough, put it on the actual Google Doc, insert the image, and I'll look at that. And I'm also going to attach a couple websites that you can look at with like a digital thermometer and a temperature game. Those are optional, but I encourage you to do them. And as always, just do your best with the work. If you haven't figured it out yet, if I'm not happy with what you're doing and I'm looking at everything, okay, there's nothing that's coming in that I'm not looking at, I send it back to people and you have to do it again. So just do it right the first time and put your best effort in, okay? So remember, today's work for Thursday is also Friday's work. There will not be a new assignment until Monday. And remember, Friday is not a fun Friday. If you do everything on Thursday, then you have Friday off, but you can also space it over 2 days. And also, if you're missing any work, use this time, all right? So again, I hope everything is well. I'll be around if you need any help. And just keep in mind, hot likes to go to cold. Okay, so hot to cold is the way that it occurs. Really, cold doesn't even exist. Cold is just basically when heat leaves something. So if you've ever touched something that's cold, like let's say an ice cube, the ice cube is really not cold. What's really happening is, this is weird, the heat leaves your hand. Remember, hot to cold, your hand's hotter than the ice cube, and that makes it feel like it's cold because the heat's leaving your hand. If you touch something that's hot, okay, hotter than your hand, okay, it's the opposite of that, what's happening, okay? So the heat leaves that object and goes into your hand, which makes you get burned because all that heat's coming into you, all right? So enough of me. Sometimes I can get going on my tangents, as you know, but good luck with the work today. Keep doing your best, and I'll speak to you soon.